Good day. So this is the part 2 for grade 10 financial maths. So we are saying inflation. Inflation is the average increase in the cost of goods, services over a period of time. So when that increase in the prices that we have, what is referred to as inflation. So like what you see if there's an increase in petrol price, that's also part of inflation. And the rate of increase of petrol price, if it continues to increase, it can affect the country, what you call as economy, because we are saying the inflation rate should be actually be managed and also should not be high, should not be high. And we are saying here, if we are to have, and we just want to do examples here. So the first example is 2 kg of sugar at a local supermarket cost 12 Rand 50 at the end of 2010. So whenever you see inflation, you must think of compound interest. That's what's important. Whenever you see inflation, you must think of compound interest. We use compound interest formulas. Then we are told that 2 kg of sugar at a local supermarket cost 12 Rand 50 at the end of 2010. How much will you be paying for 2 kg of sugar in 25 years? Assume that the average rate of inflation over the next year is 25 years, and so next 25 years is 7.2% per annum. Then there's the B, how much did a 2 kg of sugar cost 25 years ago? Assume that the average rate of inflation over the last 25 years was 11.3% per annum. So here, what we need to do for A, we need to write the formula for A is equals to P1 plus your I, which is your interest, to the power of N. And what are we given in this case? A, let's see if you are given A, how much will you be paying for 2 in 25 years? So A, we are looking for A, how much in future will you be paying for that? Then P, we are told that is 12 Rand 50 cents. Then your I, what is your I there? Your I, we are told that is 7.2%, 7.2%, which is 7.2 2 over 100. Okay, then what is our N? Our N is 25, because we're told that is over 25 years. Now let's get to calculations now and see what we have there. So we're gonna say this is gonna be equal to what? This is gonna be equal to, what is our P? Our P is 12 Rand 50, 12.5. Then 1 plus, what is our I? 7.2 over 100 to the power of what? To the power of 25. Then we can punch our calculator. Okay. Now here, what are we going to get here? 12.5. What is it in bracket? 1 plus 7.2 over 100. We put that in bracket as well to the power of 25. What do we get there? We get 71 Rand, 0.9. Okay. When you're dealing with money, you must round off to 2 decimal places. Okay. So your final answer, if it's not specified, you round off to 2 decimal places. Then let's move on to the question B. So this is how much it will be costing in 25 years. It will be costing what called 25 Rand per what you call the 2 kg. Okay. Then let's move on to the next question. It's saying how much did a 2 kg sugar cost 25 years ago? So we are saying here, we are still using the same formula. A is equals to P1 plus I to the power of N. But in this case now, our A is not given. We are looking for A is given because we are told that how much did a 25 25 2 kg sugar cost 25 years ago? Okay, assume that the average rate of inflation was that. Now we are saying A in this case here is 25 what? A is this case is 12 Rand, 5. That's the current price. And P is what we need. Principal 20 years ago, how much was it? Then we have got our P there. The one in question, sorry, is the one in question, the one that we are looking for. Let's wrap here. We are looking for P. Then our I is still what? 11.3%, which is 11.3 over 100. then our N is equal to 25. Then what are we going to do here? We're going to say A is 12 Rand 50 is equals to P in bracket 1 plus what is our I 11,3 comma over 100, sorry, over 100 to the power of N. What is our N? 25. Then our P there should be equals to 12 Rand 5 over 1 plus 11,3 over 100 to the power of 25. Then let's see what we get there. 12 Rand, 5 divided by, we put the bracket 1 plus your I 11,3 over 100 to the power of 25. Then what do we get there? We get, it was costing 0,86 Rand. So it was costing 0,86 Rand. So 86 cents. It was costing 86 cents 25 years ago. Okay, that's what it means there. So you must always remember that what am I being asked of? And you write your formula first, then you see what is missing. That's actually to help you a lot, because you must know what is the question, what is that you need to find at that particular time. Now let's move on to what we call population growth. Population growth, again, you're still using the same, the way population grows, the way inflation grows is actually behave as what we call compound, formula. So use the same thing, compound interest formula, that's what you use. Now we're saying population of Mpumalanga was 3.4 million in 2010. Calculate the expected population of Mpumalanga in 17 years time based on an annual growth rate of 1.3%, which is annual growth. Annual is per year, so annual growth is more like 1.3% per annum. So we are saying we are still using the same formula. A is equals to P 1 plus your I to the power of N. But what is it that we want here? Our A is the one in question. What is our P? Our P is 3.4 million. Then what is our, what is what else? N is 17. What is our time? Our interest is 1.3 over 100. Okay. Now, what are we going to do now? We substitute 3.4. So 3.4 million, you can either expand it as 3.4 million, or you can just write it 3.4, but knowing that your unit must be million. Okay, must be million. So you're gonna say use 3.4 in a bracket, 1 plus what is our I? Our I is what? Is 1.3 over 100 to the power of 17. What do we get there? We're going to write 3.4 in bracket 1 plus 1.3 over 100 to close there to the power of 17. Then what do we get? We get 4.23 million. So you can even write it like that, 4.23 million. That's what it means. Okay, so it's going to be 4.23 million. In this case, you know that if you are saying million, this can actually cancels everything. It's not like we are saying the population is existing as comma. Okay, but because of the million, we know this is just like 4,230,000. That's what it means. What you call people. That's the 4.3. Okay, so 4.23. Now let's move on. Impala population increased from 34,400 in 2000 to 48,200 in 2011. Calculate the annual percentage increase in what? In Impala over 11-year period. So A, we still use the same formula. A is equals to P 1 plus your I into the power of N. What is that we want here? A, we are given accumulated amount is 48. Then our P is what? Our P is 32,400. Then our N is 11. Our I is the one in question, because we want to know annual percentage increase. This is our interest that we're looking for. We are looking for the interest in this case. So what are we going to do here? We put all our values. We're going to say what? 48 48,200 is equals to 32,400 in a bracket 1 plus, what is our I? 11 over 100. Oh, sorry. Our I is the one in question. Our I is the one in question. Then your N is 11. Okay, then what do? We divide both sides by 32,400. 32,400. We're going to say 48,200 divided by 32,400. Then what do we get there? We get 1,48. So in this case now, we don't have to round off too much. We have to say 1,48 because we haven't reached the final answer yet. So you can just write almost everything, but it's fine. Then you can get a more accurate answer there. You don't have to round off before you reach the answer. Then you're saying 1 plus what? 1 plus I to the power of 11. And remember what we said earlier on in our first lecture for finance, we said when we have this, you have to what? You are going to say 1 plus your I is going to be equals to root. We'll put 11 here, then 1,487 6 5 4 3 2 1. Now here, what do we get here? We're just gonna say root answer. We get what? What do we get? We get 1,2196. So we're going to say 1, so this is gonna be 1, 9694 goes on like that. Then here we're going to take the one that side. I is going to be equals to 1,2196994 minus 1. Then we get minus 1 here. We get what is it? We get 0,21, which is 21,0,219,694, which is approximately what? Times 100, remember, then we get 21,97%. That's what it means there. Okay, so you don't have to write the percentage when it is a decimal like this. You must multiply by 100, so you write a percentage. Okay, so that's what you must always remember. So don't, when you get 0,21, you're like, oh, so the percentage is 0,21. No, it's not 0,21. You say times 100 to get to your percentage. Okay, I hope you guys understand. That's what the increase is actually 21,97%. Now let's move on. Exchange rates. So we need to know that when you're dealing with currency, there is an exchange rate that is there. Like here, for when you're saying the table, let's look at the table here. The table gives the exchange rates of foreign currency against the South African rand at the beginning of January 2011. Now, this is what it means when we are saying these are rands. Okay, these are rands. So this is the 1 US, what called the pound, 1 euro. How much now that is it? That's what we're saying here. So we're saying for every 1 US dollar, we need to exchange with 6 rand 89.81. For every 1 euro, you change it with what you actually change it what is equivalent to 8 rand 91. That's what it means here. Okay, so this means it's 1 euro equivalent to 8 rand 91 cents. So I must put the rands so that you can understand much better there. Then we are saying gold is trading at 1,243 per ounce on the international markets. Now, so we're looking at the solution now. So our owner A, determine the income in South African rand if 2,000 ounces of gold is sold. So here you are saying 1 ounce is what? It's 1,200. So first of all, we need to calculate the total in terms of rands. So we're going to say in terms of dollars, sorry, we're going to say 2,000 ounce times 1,243. What do we get? What do we get there? If we say 2,000, right, going down here, 2,000 times 1,243. We get 240. Is it? Let me see here. Okay, 2 million. It's going to be 2,486,000. These are dollars. These are dollars. And now, when you have got these dollars, we know that $1 is equivalent to what? $1. $1. $1 is equivalent to 6 Rand 81. So it means that if we're going 2 million, we're going to say that 2 million, our answer is there, times what? Times 6,681. 6,81. What do we get? We'll get okay, it's gonna be 16 million. Gonna be 16 million Rand. So you can see how much money you'll be getting there in rands. Now, the second question is saying, calculate the additional income from the sale of gold if the exchange rate was 9 Rand 80 to US dollars. So we are saying, what about if it was 9 Rand, $1 equivalent to 9 Rand 80. Then it was going to be 2,486,000 times 9,8. 9,80. Then we would see what we get there. We're going to get, say, 2,486,000 times 9,8. We see what we're going to get there. We're supposed to get 24 million. So let me just write it, put it here. 24,362,800. Now, so it means that this is what you're supposed to get there. So they're saying calculate the additional income. Additional income, now how do we get it? We subtract the 2. So it's going to be additional here, income, that's what we need to get the answer. We're going to say 24,362,800 minus 16,929,66. Then what we get there, minus this, minus 16,989,66. Okay, then what do we get there? We're going to get additional of 7,433,134. I hope one of you guys, you'll be also dealing with these millions in future, okay, in real life, in your accounts. I wish you what you call to be also millionaires. Okay, now let's move on here. What are the advantages of for the mines if the rand is weak relative to the dollar? So it means that you will have more money. So mines will receive more money. So if this is what it means, if here when it's 6 Rand 81, we are saying the rand is strong, and in this case when it's 9 Rand 80, the rand will be weak. So that's what you must know. The rand is weak. So here when it's $1 equivalent to 681 Rand. This is what we're saying. It is strong. Rand is strong. Strong Rand. Then when $1 is equivalent to 9 Rand 80, the rand is weak. Weak. Because you need to pump out a lot of money to get $1. That's what it means. So it means, but now in this case, now we are selling your gold in what? In dollars. So it's an advantage to the mines that when it's weak. So that's what you must understand. This is currency. When it's weak, you find that some people benefit. When it's strong, some people also benefit. That's how it works in the market. Okay. So here it means that the mines will get more money. Or should we say revenue? Okay, so that's what it means then. Then Number two, a South African teacher works in England for 3 years and saves 600 pounds each month. Now calculate how much money she would have saved in rands over 3 years. Now we are told that each month, so we know that 3 years is equal to how many years, how many months? 3 times 12. What do we get? 3 times 12, 36 months. Now we're told that each month is saving that amount, okay? So it means that 600 times 36 okay, what do we get? 36 times 600, we get 21,600. 21,600 pounds. But what do we also know from our exchange rate table? They are saying what? 1 pound. Where is the pound now? Okay, British pound. British pound is 1 British pound is equivalent to 10.47 rands. That's what it means. So it means that what we're going to do, we're going to say 21,600 times 10.47 to get it in rands. Then we're going to say times 10.47. What do we get? 226,152. Okay, 152. That's what we get there. So this is what the amount that you get, what you call the teacher will be having in 3 years, over 3 years. Okay, so let's move on to the last part. Now, this one here is for you to understand what called the timeline, using the timeline, graph, so that you can calculate you solve your problems. Assume that the interest is compounded annually unless stated otherwise. Okay, Lizzie opens a savings account with a deposit of 1,000. 1 year later, she adds 2,000 to the savings account. At the end of the second year, she deposits 4,000 into the same account. At the end of third year, she deposits another 8,000 on to the same savings account. Calculate the amount in Lizzie's account at the end of the fourth year, if the interest on the savings account is calculated 11% per annum, compounded annually for their entire period. So now here is the trick, guys. Here is the trick, guys. I think I've done an example before where I said there are 2 ways to do this, but here we've got a timeline here. We are told that it's for how long? It's for how many years here? In third year, she adds that entire period, or at the end of the fourth year. So we are going to say, okay, let's have our timeline here. So this timeline is going to tell us the time. So T0, T1, let me space this. T1, T2, T3, T4. Okay, so what we are told here is that we have got this amount that is going to be added here is 1,000 rand. Okay, then at the end of 1 year, 1 year later, 2,000. So it's actually after 1 year, 2,000 rand. So I want to write it at the bottom here. Right at the bottom, okay. And write it 2,000 here. Okay, then 4,000 at the end of the second year. So here, end of the second year, which is this. So we're going to say end of the second year is 4,000. Then 8,000 at the end of the third year. So it's 8,000. Then we see that what we see here is that this money here is gonna grow. This money here is gonna grow for what? For 4 years. This one here is gonna grow for 3 years. This one is gonna grow for 2 years. This one is gonna grow for 1 year. So what we have here, N for this one is 1, N for this one is 2, N for this one is 3, N for this one is 4. That's what we are talking about then. So we are saying this will grow because it's still in the account. It's going to stay in the account for 4 years. This one is going to stay in the account for 3 years. This one is going to stay in the account for 2 years. The 8,000 is going to stay in the account for only 1 year. So we're going to see how will it grow now? What is the total now? So total here, accumulated amount, we are using what? A is equals to P1 plus your I in brackets to the power of what? N. Then now, when you're putting it now, we're going to say, to have more space, I think it's going to fit here. Let's see. A is going to be equals to P. What is our P for the first one? 1,000. In bracket, 1 plus, what is our I? Our I is 11,5 over 100 to the power of what? What is our N? 4 plus, what is the second one? 2,000. In bracket, 1 plus, what is our I? 11,5 over 100 to the power of what? 3 plus 4,000. In bracket, 1 plus your 11,5 over 100 to the power of what? 2 plus your lastly 8,000. 1 plus your 11,5 over 100 to the power of 1. Like that. That's what we're talking about there. That's how we work it out. That's how we work it out. Then now, let's see what we get there. You can punch everything in the calculator there. We don't need to stress. We're just going to punch. We have got what? We have got, let me just put it like this so that you can see. So we're going to say 1,000 bracket 1 plus 11,5 over 100 to the power of 4 plus 2,000 1 plus 11,5. Sorry. These are also mistakes that you can also make, so make sure you avoid them. Over 100 power of 3, then plus 4,000 in bracket 1 plus 11,5. This one is not pressing Y. 11,5 over 100 to the power of 2 plus 8,000. 1 plus 11,5. 11,5. 11,5. Okay, I think here I have entered a lot of values here. So let's just end there and see what we get. We get 9,290,900,151 plus 8,000, 1 plus 11,5 over 100 to the power of 1, which you can ignore, okay? Then we're going to say plus 8,000 in bracket 1 plus 11,5 over 100. We get what? What do we get? To the power of 1. To the power of 1, just we can leave it like that, okay? What do we get there? We get 18,210,90. That's what we have here is in rands, okay? That's what we're talking about there. So this is a very easy method for you to use, because the other one is going to confuse you to say this accumulated for first year, then in the first year, you add 2,000 to the one that you have accumulated, the 1,000 that you have accumulated, then you grow it for another year, then you add it to 4,000, then you grow it for another year. You add, no, this one it's not gonna lead you to the, what is it? It's gonna confuse you along the way. But this one is what you need to master. Now the 1,000, how many years does it grow? it grows for 4 years. What about the what is it? The 2000, it goes on like that. So we're saying T0, because T0, before we start even counting the year, we are saying that's your T0. T1, that's the end of the year, first year. Like if someone has got 1 year, we are saying it's actually after what call a period of 12 months. Okay, now let's move on to the next question, which is 2. 6,500 is deposited into a savings account. 3 years later, 7,400 is added to the savings. At the end of 5 years, 5,800 is withdrawn from the account. Calculate how much money will be in the account at the end of 10 years. If the interest rate is 11% per annum, compounded annually for the entire period. Now, what we need to understand here is a different scenario here again, but here now is a very tricky here. For this one, it's what called it's for. When I put it like this, I'm going to try to put it where I'm going to try to put it here T0. I'm going to skip some of the years, okay? So 3 years later, so you're saying a T3. Then end of 5 years, so T5. Then we have got 10 years now, T10. Now, here what we are saying here is that, what are we having here? At T0, we are putting 6,500. At T0. Then at T3, what are we doing? We are adding another, again, we are adding 7,400. Then T5, we are withdrawing here. We are withdrawing. So we're going to say minus. But what we see is that this 8,000, this 6,500 is going to grow because remember this one now, you need to work it, you need to be, it's tricky here because you must make sure that you have the total amount at T5. Then you subtract the 800, the 5,800, then you can carry on with the remaining 5 years. Then what are we going to do here? We're going to say, all right, this one is going to grow for how many years? For 5 years. So N is going to be 5 for this one. What about the T3 is going to grow for 2 years. So N in this case is goes to 2. You understand? Then you can add it together. So what we're going to do here, we're going to say first accumulated amount A5. Want to see how did the accumulated after 5 years? A5 year is going to be equals to 6,500. Our I in this case is what? 11 over 100. Then I think I forgot to put here I is equals to 11,5 over 100, so that we just know that. Then in bracket, we are still using the same formula. A is equal to, which is the compound formula. What is our I? 1 plus our I is what? 11 over 100 to the power of 5 plus 7,400. 1 plus 11 over 100 to the power of 2. Then what do we get there? We need to get this total first. Okay, then we say 6,500 in a bracket, 1 plus 11 over 100 to the power of 5 plus 7,400, 1 plus 11 over 100 to the power of, we square that. What do we get? We get what? What do we get there? We get 20,070. We get 20,070, 41801. Now, in this case, what are we going to do? We are going to subtract. We are going to subtract what? We're going to subtract this amount. We're going to subtract 5,800 minus 5,800. Here, we're going to say minus 5,800. We get 14,270,41801. So this one becomes our principal amount in this case. This becomes our new principal amount here. So this amount is what we're going to accumulate for the remaining 5 years. So here's a trick now. So I think you understand now this concept that this amount was you adding, you put 6,500, it grows. Then this one also growing, but after 5 years, you decided to withdraw money, but you're withdrawing money from the accumulated amount for the 5 years. That's why we are doing this now. So when you do that, when you remove that 5,800, what you are remaining with is your new principal amount. Then it's going to grow for the remaining 5 years, because the entire period is 10 years. Okay. The entire period is 10 years. So now we're going to say your A for the 10 years is going to be equal to, for the 10 years remaining, so it's going to be equal to 4,800, 4,270. Is it correct here what I'm writing now? 4,270, 41801 in bracket 1 plus, what is our I? 11 over 100 to the power of what? What is our N? 5 years. Because what's remaining is 5 years. Okay. Now what are we going to get there? It's gonna be 14,270, 41801 in bracket 1 plus 11 over 100 to the power of 5. What do we get there? We get 24,046,48 rand. And here's the trick again. That's what you see. I didn't round off here because I haven't reached the final answer. That's why I didn't round off here. You don't round off before you reach the final answer. You round off when you get to the final answer. Okay, so here you can be able to actually round off and get the correct answer. So some of your answers you might find that they will be wrong because of your rounding off earlier. Okay, you mustn't round off before you read the final answer. Even here you see I didn't round off because I haven't read the final answer. Okay, I hope you also do that in your questions. Okay, thank you so much and all the best.